Okay, picking up on number 76. We're still finding the slope. So let's see. We have a point down here. It's clearly passing through. That's 0, -2. Sorry, the copy's not great, but there's also a point, let's see, going through, yeah, right there. It's 1, 1. I'll have them more clearly labeled if there's one like these in the exam, I assure you. But once we get those 2 points, we follow the same process we did on 72 to 75. We do y2, which I'll call the point on the left, the first term, point on the right, the second term. So I'll treat this as x1 and y1. This is x2 and y2. So y2 minus y1 over x2 minus x1. So I change the minus and negative to a plus. That gives me 3 over 1, or 3 as my slope. Okay, here's a point on 77. That's the point -3, 2. And looks like we hit the x-axis right here. So that'd be the point 2, 0. Again, I'm just going to treat the point on the left as x1 and y1. The point on the right is x2 and y2. So I do y2 minus y1 over x2 minus x1. 0 minus 2 is -2. I change minus a negative to plus a positive. 2 plus 3 is 5. Oh, sorry, I'm out of vision there. So -2/5 is the answer for 77. Okay, I did make sure, let me put this in view, hold on. I labeled these points clearly. So we're trying to write an equation in slope-intercept form. So this time we're given a graph and asked to find the equation. Okay, there's a couple ways you could approach this. The one I think is personally easiest is if they give it to you, look at the y-intercept. It's right here, 0, -1. So I know right away I have y equals whatever the slope is times x minus 1 because my slope-intercept is -1. Now to find the slope, you can label this point, which is -2, 3, and do the slope formula. That'll work fine. I'll show you. We get y2 minus y1 over, sorry, I did it backwards. We'll treat this as y1, or the second point, sorry. -1 minus 3, so that's y2 minus y1 over x2 minus x1. So -1 minus 3 is -4. And this ends up 0 plus 2, which is 2. So we get a slope of -2. So that's one way you can find the slope. Another way is to just use the rise over run method, meaning start at this point on the left and count. We have to go down 1, 2, 3, 4, and go over 1, 2. So we went down 4 and over 2, which also gives us a slope of -2. On 79, we'll follow the same process. That's the point 0, 1. So I know this one, the y-intercept is plus 1. Have to find the slope. You can label this, then do the slope formula. I'll leave that to you. We've done plenty of those. Or you can just count. We go up 1 and over 1, 2, 3. So that's a slope of 1/3. Okay, 80. If the point A9 is a solution to this equation, what is A? So A, we don't know, so we just leave it as A. B is 9. So now we'll just solve for A. So 9 minus 21, we can reduce that or simplify that. 9 minus 21 is -12. Then we divide both sides by -4 to get A by itself. And a negative divided by a negative gives us a positive. So that means A is equal to 3. Okay. 81. These are absolute values. Remember, absolute value equations always take either the right side up V form or the upside down V form. And you can look at your notes to see what these things do as far as adding, subtracting, having negatives, all that fun stuff. So minus 4, when you subtract inside the absolute value, that means you move to the right that many. So this is telling us we need to shift our graph to the right of the origin by 4. Now when we're adding outside the absolute value, that tells us to move up 2. So we have to make 2 moves. We start at the origin, then we move right 1, 2, 3, 4, and from there we move up 1, 2. So that's the vertex, the center of our V. We just draw a line up that way, and we have our graph. Okay, we've got 3 things going on in 82. So first, that negative out front means we're going to have an upside down V. It's going to have that shape instead of the right side up V. Okay, plus 2, when we're adding inside the absolute value, that means we move to the left that many. When we're subtracting outside the absolute value, that means we move down that many. 3. So starting at the origin, we'll move left 2, 1, 2, then down 3, down 1, 2, 3. So that's our vertex, but because of that negative, because we have to draw this upside down, you want to make sure you draw this way. Ooh, the fun stuff we've been doing recently. You've got to commit to your memory what the different forms are. Slope-intercept form is y equals mx plus b. That being said, unless we're told what the y-intercept is, it's almost always best to start with the point-slope form. Which the point-slope form, which will also be part of 84, I'll go and write right here. It's in that format. So I'm going to use that to start number 83, but that will be my end, because I need to end with it in the slope-intercept form. So we do y minus the y value. So minus the negative 3, same as plus 3, equals the slope, which they tell us right here, x minus the x value, which is 7. So this is a correct equation for this line, but it's not the form they asked us to complete it with. So this is a good start, but it's not the finish. To finish, we need to distribute the 4. 4 times x is 4x. 4 times 7 is 28. And for our final step, to get y by itself, because that's what we want, we subtract 3 from both sides. So our final answer is y equals 4x minus 31. Okay, 84, doing the point-slope form. So this is actually a lot quicker because we can do that right away. We can do y minus the y value, which is 3, equals the slope, which is negative 2/3, times x minus the x value, which is 4. Okay, 85 is similar to 83. We'll have to do the point-slope form first. However, we got to finish with y equals mx plus b. And they didn't give us a slope on this one. They just gave us 2 points. So our first step on this will actually be to find the slope. So we'll do y2 minus y1 over x2 minus x1. So those both change to positives. So 4 plus 2 is 6. 3 plus 2 is 4. And that reduces to 3/2. So we have a slope and we have a point. And you can pick whichever point you want. It doesn't matter if you use this one or this one, you can pick. I'll just use this one, but it doesn't matter either way. So I'll do y minus the y value equals the slope times x minus the x value. So first step is to distribute the 3 halves. 3 halves times x is 3 halves x. Okay, 3 halves times 3. 3 times 3 is 9. So I need a minus in there. 9. And then 2 times 1 is 2. So sorry about my handwriting. That's 3 halves x minus 9 halves, which that's 4.5. You are allowed to use your calculator on these problems. So the last step is to add 4 to both sides. And I'll accept it if you have this in decimal form or fraction form, whatever you prefer. So that's negative 4.5 plus 4. Oh, sorry, that's gone now. Try that again. So I canceled out the 4. Give me 3 halves x. Negative 4.5 plus 4 gives me negative 1/2 or negative 0.5. You could write it either way. Okay, 86. Very similar to 84. Right in point slope form, so that's y minus y1. So we do y minus the y value minus negative 3, same as plus 3. Our slope is negative 9. Then we do x minus the x value. X minus negative 1 is plus 1. And you're done. '87 is also quick that way. We do y minus the y value equals the slope times x minus the x value. Minus the negative 2 is the same as plus 2. Okay, standard form. That's ax plus by equals c. So we want to get this in standard form. Our first step would be to distribute the 2. And then to standard form, we want the x and the y both on the left side. So I'll subtract the 2x, and I'm going to put it out front. And let me put my worker here. Okay, so we've got the x first, the y second, but we don't want that 4 there. We want the numbers all on the right side. So I'll subtract 4 from both sides. Give me negative 2x plus y equals negative 5. Oh, hold on, sorry. I forgot my distribution here. 2 times x is 2x. 2 times 1, that should be a 2. So negative 2 minus 4 is negative 6. Sorry about that. Again, I forgot to distribute the 2 to the 1. So it should have been 2x minus 2. And then negative 2 minus 4 is negative 6. There's one more thing. Standard form can have negatives anywhere except for the a. The number in front of x cannot be negative. So to fix that, we'll have to multiply everything, all 3 terms, by negative 1. So that just changes the sign of everything, making it a positive 2x minus y equals positive 6. '89, we want slope-intercept form. This one's easier. We just distribute the 3. And then add 2 to both sides. And there you go.